All right, welcome to the 8.1 notes. We're going to be talking about samples and populations. All right, when we're talking about a sample, we can talk about some samples that are biased and some samples that are unbiased. So I'm just going to read the definition. You should write it down. An unbiased sample is a representative of a population. It is selected at random, and it's large enough to provide accurate data. And then a biased sample is not really a good representation of the population, and it's also like it has one or more parts that favor something. So we'll talk about that. But if you have those written down, make sure you pause the notes, write those down, because you're going to need that as we're going through the examples. All right, so let's take this first example. It says if you want to estimate the number of students at a high school who ride the bus to school, we want to see which sample is unbiased, right? And if you remember, unbiased is something that could be random and large enough to provide accurate data. So let's look at this. 4 students in a hallway. All students on a soccer team, 50 12th grade students at random, 100 students at random during lunch. So that's kind of what we're talking about. Which one would be an unbiased? Well, first of all, we should be able to see some ones that are obviously not biased, or right, or are biased, obviously. 4 students, is that going to help us? No, we want a big sample. And also, what about B? Just the kids who play soccer? Not good enough. We need more than that. What about just 50 12th graders? Not good enough. But 100 random students at lunch, that's probably going to be good enough to give us our sample. It's not going to be biased. It's going to give us what we need. And that's what it's saying. Conclusion made from sample C may be inaccurate, right? And obviously D is going to be the answer. So correct answer is D. So if you follow along with that example, you saw why that made sense and why it worked. Let's do a different one. All right, this next example is for you. I hope you read it, but you can see it. You want to estimate the number of 12th grade students in a high school who ride the bus to school. Which sample would be what you want to use? Which is the unbiased example? Take a look. Is it A, B, C, or D? All right, you should have selected C because you want to know more about the 12th grade. C is the only one that talks about the 12th graders. So good job. That one is the unbiased sample, the sample you want to use. All right, in the next part of problems that we're going to do, we're going to determine whether conclusions are valid, meaning if a survey is done and the survey is good enough that we can use the survey. Okay, so let's check it out. You want to know how the residents of your town feel about adding a new landfill. New landfill is where you put all the garbage in town. So determine whether each conclusion is valid. So A, it says you survey 100 residents. That's people who live, right? People who have houses and rent, who live closest to the new landfill. The diagram shows the results. You conclude that 10% of the residents of your hometown support the new landfill. All right, so you can see that. We have 10 people for it, 90 are against. So here you go. Look at B. It says you survey 100 residents at random. The table shows the results. The table is the one on the left here. You conclude that 60% of the residents of your hometown do not support the new landfill. So look at the difference. We can see that people living right next to the new landfill, 90% or 90 out of 100 are against it. But then when we just ask people at random, we get 60-40 split. 60% are like, yeah, I mean, we don't support it. 40% are like, yeah, it sounds good. Okay, so that's what we have. And now, what do we find out? This sample, obviously, is not a good representative, right? Because they're definitely not going to support it because they live right next to it. So this sample is biased, and therefore the conclusion is not valid. Okay, what about the second one? What do you think? Do you think this one's a good sample size? It's a good one of the population, representative of the population, because it is selected at random and is large enough to provide accurate data. So that one is good enough. So that one's unbiased. So you would want to choose B, not A for that one. So based on the same one about the landfill, we have a new question for you. You want to know how the residents of your town feel about adding that landfill, right? 4 out of 5 randomly chosen teenagers support the new landfill. So you conclude 80% of the residents of your town support the new landfill. Is this conclusion valid? So make a guess right now in your head. Okay, you should have said no. Why? Because it's not enough people. Okay, it's small. It's 4 out of 5 randomly chosen teenagers. Are teenagers homeowners? No, they don't even know everything that's going on. So unfortunately, that would not be a good and valid sample. Okay, on the next example, you ask 75 randomly chosen students at school how many movies they watch each week. There are 1,200 students in the school. Estimate the number of students in the school who watch one movie each week. So we see there's 21 that were surveyed that watch one movie. 30 people said 0, and 24 people said they watch 2 or more movies. Looking at the pie chart to the right there. So first of all, we need to understand the problem. You are given the numbers of movies watched each week by just a sample of 75 students. You're not sampling everybody in the school, and that's okay. That's what happens when people pick surveys out. They don't survey every single person. So you're asked to make an estimate about the population for the whole school. So the sample is a representative of the population because it's selected at random. It's large enough to provide accurate data. So the sample is considered unbiased, and then the results are proportional to use. So now you could say, you could set up a proportion. You could say, hey, well, 75 over the 1,200, and you can say, well, how many watch movies? Well, you can say 21 out of X, and then you can figure out, well, if 21 out of 75 watch one movie a week, you can times that and set up a proportion to do that, and that's kind of what they'll show here. So if you have 71 over 75, then what over 1,200, right? We're setting up a proportion, and then from here, you would multiply that out, and you would see, oh, well, about 336 students watch at least one movie a week, and then you can look at the sample for the other ones. You can just keep going. So about 336 students watch one movie a week. They did it a little bit different. I would have just went 21 over 75 equals X over 1,200, and we would have got the 336 that way by cross multiplying. So a little bit different than what we're used to there in the example shown. All right, so as you're doing the 8.1a, it's more or less what we just did. You're going to identify the population, right? Is it biased or unbiased, right there? Numbers 1 and 2. Then you get to number 3. Determine whether it's unbiased. Looks like you're doing that in the same. Well, hold on. In number 1, yeah. So you're just going to identify it. What is it? All students in the school or 30 students in the school? 75 strawberries in the field, all strawberries in the field. Okay, what are we looking at? Number 3, is it biased or unbiased? Same thing with 4. And then when you're looking down the screen, you're making estimations. So which sample is better for making an estimate? You're going to read A, you're going to read B. And you're really going to have to think through things. And I know a lot of us, we don't like to read. So we don't want to read these kind of problems. But they're going to be nothing but reading in Chapter 8 and really analyzing things. So it's going to be more reading, thinking, and then coming up with things and be able to explain why. So that's going to be the majority of it. So feel free to work through that, look at the charts, and we'll check our answers as we go. All right, that's all we got. Those are the 8.1 notes.